Yeah. So very good evening to all of you. So we are discussing the biomolecules chapter, right? So we have completed carbohydrates and proteins part. So today we are going to see what are enzymes, what are vitamins, nucleic acids and hormones. Okay. So each and every one is a very small topic. So we can mostly complete the lesson by today. All right. So let me go ahead with enzymes. So what are enzymes? Enzymes are biocatalyst. Okay. The very important point about enzyme is they are biocatalyst. So in one of the previous year NEET examination, they have asked this. Enzymes are biocatalyst and they are responsible for the smooth and biological activities in the body. Okay, catalyst means you all know the one which alter the rate of the reaction is called as catalyst, right? So enzymes are the biological catalyst, that's all, which is responsible for the biological activities in the body. All right. And almost all the enzymes are globular proteins. So we have studied about two different types of proteins in the previous class, right? One is fibrous protein and the other one is globular protein. Globular protein means the one which is spherical in shape, okay, and they will have globules, so etc. So the enzyme is basically a globular protein. And enzymes are very specific in their work, okay? So we have different types of enzymes and one particular enzyme can do only one work. Okay, so they are very specific in their work. So these are the four important points you should know about enzymes. Okay, they are biocatalyst, they are responsible for the biological activity, they are globular protein, and they are very specific. All right. So these are the points about enzymes. Now let's study the naming of enzymes. So there are two classification here. First is the naming based on the compound or class of compounds upon which they work. The second naming is based on the reaction. Okay. So first I will give you one example for the first classification, which is based on the class of compounds upon which they work. So I have taken a compound called maltose, whose formula is C12H22O11. Okay. If this maltose is treated with water, it will give two molecules of glucose. Okay. And for this reaction, the enzyme that is needed is called as maltase. So why it is called as maltase? Because it is reacted, it is treated with maltose. So that's why the name of the enzyme is maltase. Okay, so the work, it is doing the work on maltose, so it is called as maltase. Okay, so on the other hand, based on the reaction, listen, an enzyme, for example, can do oxidation as well as reduction. Okay, suppose if I have two components in my reaction, it will oxidize one compound which is A and it will reduce the another compound B. Okay, so the enzyme can be named as oxidoreductase. Oxidoreductase. So based upon the work they are doing, okay, class of compounds upon which they work, so we can classify the name and based on the type of the reaction. Since they are doing oxidation reduction in a particular reaction, the name of the enzyme is oxidoreductase. Okay, so these are the two classification from which we derive the name of the enzyme. Mostly, if you see to the names of all the enzymes, they end with the suffix ASE. Okay, so in all the enzymes, most of the case, they end with ASE. Here also, if you see in both the cases, they end with ASE. So ASE is the most common suffix that all enzyme has. All right. So now let's go into the mechanism. Let's see how the enzyme acts as a biocatalyst. Okay. So let's study the mechanism of enzyme catalysis. So enzyme, what do? They increase the rate of the reaction. Like other catalysts, enzymes are biocatalysts, right? So they will increase the rate of the reaction by lowering the energy of activation. So if I draw the graph between reaction coordinate and energy, suppose if I have the reactant here and the product here, the reactant will be converted to a product, right? And this is the activation energy of the reactant without enzyme. Okay, suppose if this much of energy is required to activate a compound, then in presence of enzyme, very less amount of energy is enough to activate that particular complex. You see here, the activation energy is getting reduced, okay, in presence of enzyme. So with enzyme and without enzyme, activation energy is getting reduced. So enzymes are acting as the catalyst. Enzymes are increasing the rate of the reaction by decreasing the activation energy. Okay, so easily within a very few minutes or few fraction of seconds, the reactant can be activated with the help of the enzyme, and the reaction will occur and the product formation will be there. Got it? So this point is very important, the mechanism. So they increase the rate, they increase the speed by lowering the activation energy. All right. So do you guys have any doubt in enzymes? So initially I have discussed 4 points about enzymes. Then after that we have classified their names based on the work and based on the reaction. And thirdly, I have discussed the mechanism of enzyme catalysis. Is it clear to all of you? Bharat, Suraj, Christina, Priyadarshini, do you have any doubts in this enzymes? Enzyme is getting over here. That's all about the enzymes. Next, we have to go for the fourth biomolecule, vitamins. Guys, tell me, do you guys have any doubt? Any doubt for anyone? Okay. All right. So then let's go ahead with the next class of biomolecule, which are called as vitamins. So what are vitamins? What are vitamins? Can anyone tell me what are vitamins? Can anyone tell me what are vitamins? Okay, I will tell you. The organic compounds required in the diet in a very small amount is called as vitamin. Okay. So why do we require the small amount of vitamins in our day-to-day life diet? They perform specific biological functions. So in the absence of vitamins, some of the biological functions may get absent. Okay. So to perform the specific biological function, vitamins are very, very important for all of us. Okay. And not only this, they maintain the optimal growth and health of an organism. So without the presence of vitamins, some of the growth or some of the biological function may get stopped. So the vitamin is very essential for all the human beings. Okay. So to maintain the growth and the health of any organism, not only human beings, for any organism, vitamin is very much essential. Got it? So now let's go for the classification of vitamins. So the first classification is based on their solubility in water or fat. Solubility in water or solubility in fat. So according to the solubility, it is classified into two. One is called as fat soluble vitamin and the other one is called as water soluble vitamin. Okay. So fat soluble vitamins means they are stored in the liver and in the adipose tissue. Got it? They are stored in liver and adipose tissue. And the examples are vitamin A, D, E, K. Very important. So you should know the vitamins which will come under fat soluble vitamins. Okay, A, D, E, K. Then coming to water soluble. So water soluble vitamins readily excreted in urine and cannot be stored. So fat soluble vitamins are stored in liver and adipose tissue. Water soluble vitamins cannot be stored. Okay, they are readily excreted in the urine. Okay, so what need to be done? They must be supplied regularly in the diet. Since they are getting excreted every day in the urine, you should you should take the water soluble vitamins regularly in your day-to-day diet. Okay. So the examples of water soluble vitamin are vitamin C and vitamin B group. Vitamin C and vitamin B. Clear? So just study the examples. They are very important. And you should know which one is stored and which one cannot be stored. Okay. They are stored in liver and adipose tissue, right? This is also an important thing. So AD, except ADEK, all other vitamin C and B will fall under water soluble vitamin. Clear? This is all about the vitamins. Now the next is nucleic acids. What are nucleic acids? So nucleic acids have two types. Okay, they have two types. One is DNA and the other one is RNA. So what is meant by DNA? DNA is called as deoxyribonucleic acid. Deoxyribonucleic acid. You might have studied in your biology, right? So DNA is called as deoxyribonucleic acid. And RNA is called as ribonucleic acid, right? They are ribonucleic acid. So nucleic acids are mainly the long chain polymers of nucleotides and are also called as polynucleotides. Okay. So the nucleic acids are called as polynucleotides. Got it? So now let's study about the nucleotides. Let's study the chemical composition of nucleic acid, not nucleotide, nucleic acid, chemical composition of nucleic acid. So the complete hydrolysis of DNA or RNA has pentose sugar, phosphoric acid, and nitrogen containing heterocyclic bases. Okay. So if you completely hydrolyze the DNA or RNA, you will get a pentose sugar. And the second is phosphoric acid. And the third one is nitrogen containing heterocyclic bases. Okay. Now, let me start with the sugar. There are the three components, right? Let me start with the pentose sugar. So, pentose sugar means the specific name of the sugar that we use here in DNA is beta D ribose sugar. Okay? Beta D ribose sugar. And the other one, in DNA, we use deoxyribose sugar. So what is the difference between these two? So to the second carbon, we have an OH here, right? So that oxygen would be removed here. So that's why it is called as deoxy. So the oxygen at second position is removed in the second case. That's why it is called as deoxyribose and this is called as ribose. Okay. So beta D ribose will be present in RNA and the deoxyribose will be present in DNA. Okay. Now the second component is phosphoric acid. So what is the formula for phosphoric acid? H3PO4. H3PO4 is called as phosphoric acid. So this is the phosphoric acid component. And the third one is the nitrogen containing heterocyclic base. So who are those nitrogenous bases or nitrogen containing heterocyclic base? Purines and pyrimidines, right? Purines and pyrimidines. So who are the purines? Adenine, guanine. These two are the purines. And the pyrimidines are cytosine, thymine and uracil. So these three are the pyrimidines. Okay. So in case of purine, we have one 5-membered ring and one 6-membered ring. So it is a 6-membered ring, right? 1, 2, 3, 4, 5, 6. And here 1, 2, 3, 4, 5. It is a 5-membered ring. And here also in the second purine, in guanine also we have one 5-membered ring and one 6-membered ring. But in case of all the three pyrimidines, we have a 6-membered ring only. So this is one very important thing you need to know. So purines have both 5-membered and 6-membered ring. Pyrimidines will have only one 6-membered ring. Clear? So these two are the nitrogenous bases. These two are the nitrogenous bases. Okay. So any doubts so far? in the sugar and in the phosphoric acid part and in the nitrogenous bases part for anyone? Shall we go ahead with the next slide, students? Any doubts so far for anyone? Let me know fast. Let me know fast. Shall I go ahead? Any doubt till this? Any doubt in this? Am I audible, students? Am I audible? Can you able to hear my voice? You want to ask anything? Bhagat, am I audible? Suraj, Bhagat, Piali, Jabrun Sultana. Can you able to hear my voice? Yes. Shall I go ahead? All right. The next topic is nucleoside and nucleotide. Okay, nucleoside and nucleotide. So let's study about these two terms. Attachment of a base to one prime position of the sugar. This is the sugar molecule, and this is carbon number 1 prime, okay, and a base is attached to it. Attachment of a base to one prime position of the sugar molecule is called as nucleoside. Okay. So what are nucleotide? Nucleotides are attachment of the nucleoside to phosphoric acid at a 5 prime position of the sugar. So what is nucleoside? Base with sugar is called as nucleoside. Base with sugar is called not only this. Listen, base with sugar is called as nucleoside. So attachment of this nucleoside, okay, to phosphoric acid, okay, at 5 prime position is called as nucleotide. Phosphoric acid with nucleoside is called as nucleotide. Clear? Clear for all of you. So base and sugar is nucleoside. Base plus sugar plus phosphoric acid is called as nucleotide. All right. Now let us discuss the bonding in nucleotide. So let me take one nucleotide where I have a base, sugar molecule and the phosphoric acid. In the same way, let me take another molecule of nucleotide. Now, how does a bond form between these two nucleotides? It is by the removal of water. Okay. So the 3 prime end containing OH and the phosphoric acid OH will give out water molecule. H2O will be removed and there is a formation of oxygen linkage. Okay. There is a formation of oxygen linkage. This is the 5 prime end of the chain and this is the 3 prime end of the chain. So this is actually the 3 prime end of the chain and the 5 prime end of the chain. They form a linkage here, which is called as phosphodiester linkage. And this is the bond formation in nucleotide. Okay. So that number is very important. 3 prime and 5 prime end of two nucleotide will form the bonding, which is called as phosphodiester linkage. Clear? So this is all about the nucleic acids. This is all about the nucleic acids. Okay. Now the last biomolecule is called as hormones. So now let me introduce the hormones to you. Hormones are intercellular messengers. They pass the message, okay, between the cells. They are intercellular messengers, which are very important. They are intercellular messengers, okay. And they are produced by endocrine gland in the body. The name of the gland is endocrine gland. They are produced by endocrine gland in the body. Examples. Examples of some steroids are estrogen and androgens. Okay. And if I want to give an example of a polypeptide, then insulin will be the example. So these are some of the hormones, examples for hormones, estrogens, androgens, and insulin. Okay. Not only this, let's study about some more important hormones and their function. So let me take insulin. So you all know why insulin is used. Okay, right? So insulin actually maintains the blood glucose level in the body, right? It maintains the blood glucose level in the body. So glucose will be converted to glycogen with the help of the compound called insulin. And glycogen can be converted back to glucose with the help of glucagon. Okay, the name of the compound is called as glucagon. So if the insulin production is very less, or if the insulin secretion becomes very less, then what will happen? They cannot maintain the glucose level cannot be maintained by the body, right? So that's why we take insulin injection and insulin tablets, etc. Okay. So insulin is one of the very important hormone for our body. Clear? Then the next hormone is thyroxine. Can anyone tell me where does this thyroxine is getting produced? In which gland it is produced? Can anyone tell me the name of the gland that thyroxine is getting produced? So thyroxine is produced by which gland? Students, come on, don't feel shy. You might have studied all these things in your biology, right? So try. Thyroxine is produced by which gland? The answer is already there in the name itself, right? Name of the hormone. They are produced by thyroid gland. Thyroxine is produced by thyroid gland. Okay, so it is the iodinated means iodine containing derivative, iodine element containing derivative of amino acid tyrosine. It is iodinated derivative of amino acid tyrosine. Tyrosine is the name of the amino acid, one of the amino acid. We have discussed about 20 amino acids, right? So tyrosine is one of the amino acid. The iodine containing compound of tyrosine is called as thyroxine. It's called as thyroxine. Okay. So there are two types here also. One is low level thyroxine. If thyroxine is at very low level, then we call those thyroidism as hypothyroidism. And if it is present at very high level, then it is called as hyperthyroidism. Okay. So low level means hypo, high level means hyper. Okay. So these are the two types of thyroidism which we might already know. Clear? Now let me go for the third hormone which is called as steroid. Third hormone which is called as steroid. So steroids are produced by adrenal cortex and gonads. Steroids are produced by adrenal cortex and gonads. So adrenal cortex again has glucocorticoids. Okay. Glucocorticoids actually control the carbohydrate metabolism. Okay. So they control the carbohydrate metabolism. And one more thing is produced in adrenal cortex, which is called as mineralocorticoid. So mineralocorticoids controls the level of excretion of water and salt in the body. Okay. So there are two things, glucocorticoid and mineralocorticoid. Glucocorticoid controls the carbohydrate metabolism and the mineralocorticoid control the level of excretion of water and the salt in the body. Okay. And gonads, coming to gonads. So for male, it is called as testosterone, and for female, it is called as estradiol. Okay. So both of them are responsible for the development of secondary sexual characteristics. Testosterone in male and estradiol in female, which are produced by gonads, they are responsible for development of the secondary sexual characteristics in a human being. All right. So with this, the hormones, the biomolecules, which is called as hormone, is also getting over. Not only that, the entire lesson is getting over here. Okay. So any doubt for anyone? Now next, in the remaining few minutes, I'm going to solve some previous year's questions from this topic. Shall we go ahead? Do you want to ask anything? Any doubt for anyone? Guys, can you able to understand? Can you able to follow? So we have covered all the 6 biomolecules in this biomolecules lesson. Do you guys have any doubt from any part? From carbohydrates, proteins, what else? Enzymes, vitamins, nucleic acids, and hormones. I hope everything is clear. Fine, all right. So now let's do some previous year's questions. The very first question is the statement type question. A unit formed by the attachment of a base to one prime position of sugar is known as nucleoside. Just now we have seen, right? One prime position of the sugar to a base is called as nucleoside. When nucleoside is linked to phosphoric acid at 5 prime position of sugar moiety, we get nucleotide. Is it true? What do you think about these two statements? What do you think about these two statements? I will give you. Okay. So base with the sugar is called as nucleoside, and base with the sugar and phosphoric acid at 5 prime position is called as nucleotide. So both the statements are correct, right? Or both of them are false? What is your answer? What is your answer? Students, let me know your answer. Which one is the correct option? What about statement 1? Statement 1 is correct. A unit formed by the attachment of a base to one prime position of the sugar is called as nucleoside. Statement 1 is true. Okay. Coming to statement 2, when nucleoside is linked to phosphorus acid. Is it phosphorus acid? No. It is phosphoric acid. What acid? Phosphoric acid. H3PO4 is called as phosphoric acid. So statement 2 is false. So 1, but statement 2 is false. Option B is the correct answer for this question. Okay. Shall we go for the second question? Can you able to understand? Understanding is very much needed. Okay. If you understand the concept, then you can answer for any type of question that is being asked. Okay. Shall we go for question number 2? Shall we go for question number 2? So all the questions which you get from this particular lesson, they'll be very easy. Okay, it is a biochemistry lesson, right? So it will be easy for you guys. So I'll go for question number 2. The incorrect statement about denaturation of protein is. So in the last class, we have discussed about the denaturation, right? What is meant by denaturation? A protein nature can be disturbed in 2 ways. One is using chemical change and the other one is using physical change. Physical change means you can change the temperature, and chemical change means you can change the pH. Okay. So because of this change, what will happen to the protein? The protein will get uncoiled and they lose their biological activity and they lose their nature itself. So this is called as denaturation of protein. Now find out the incorrect statement about the denaturation of protein. So tell me which one is correct. Which is the incorrect statement? Which is the incorrect statement? Can anyone try the answer for this question? Option A says uncoiling of the helical structure. Yes. So when the protein gets disturbed, uncoiling of the structure happens and it results due to change of temperature and pH. Yes, just now I have said change of temperature means it is physical change and change of pH means it is chemical change. And it results in loss of biological activity. Yes, the protein loses its biological activity. It is also correct. So option D says a protein is formed from amino acids linked by peptide bond. Protein is formed by amino acid by peptide bond only, but there is no relation between this with denaturation of protein, right? So it is the definition of protein, but it is not the definition of denaturation of protein. Okay. So option D is the incorrect statement about the denaturation of protein. Clear? Is it okay? Shall I go ahead with the third question? Shall I go ahead with the third question? Yes. Only Bhagat is answering. What about others I do? So try to interact. The third question is D plus glyceraldehyde on reaction with HCN, H2O with H plus and HNO3. The products formed in the above reaction are. So we have to find out. So I will give you the solution. Okay. So I will give you the entire reaction. You just listen. This one is D plus glyceraldehyde, where we have one carbon which is attached to OH, CHOH and CH2OH. First, when it is treated with HCN, what happens? It is cyanohydrin formation, right? So we have C double bond O, H. So we have to break this bond, add H to oxygen and CN to carbon. So we get a cyanohydrin. We get a cyanohydrin. So the addition can be in either left side or right side. So we can have OH in the right side and also we can have OH in the left side. So we get two different types of products. Okay, we get two different types of products. Then on reaction with H3O plus, this is H3O plus, right? Then if you do the hydrolysis, the cyanide group will be converted to carboxylic acid group. The CN group will be converted to COOH group. Okay. Then thirdly, on reaction with HNO3. HNO3 is the oxidizing agent. It is the oxidizing agent, right? So what will happen? The primary alcohol part will also be converted to COOH. The primary alcohol, CH2OH, is also getting converted to COOH. So these are the reactions which we have discussed in the reactions of glucose, right? So there we had 6 carbon containing glucose and here we have taken a 3 carbon containing glucose. That is the only difference. The remaining reactions are same. Okay. So if you are taking the aldehyde and treating it with HCN, you will get a cyanohydrin. And cyanohydrin on H3O plus, you will get the COOH. COOH with HNO3, not COOH. The compound with HNO3 will lead to the oxidized product since HNO3 is the oxidizing agent. Okay. So both the compounds are optically, one of the compound is optically active, the other one is optically inactive. Okay. So you see here, one compound is optically active and the other compound is optically inactive. So why one compound is optically inactive? If I break this molecule into two, I will get two equal halves. If I break this molecule into two, I will get two equal halves. So on breaking, if I get two equal half for any type of molecule, then those molecules are called as mesoproducts. They are called as mesoproducts. So all mesoproducts are optically inactive. Okay, all mesoproducts are optically inactive. Clear? But if I break this molecule into two, I will not get two equal half, right? So OH are there on the opposite side. So they are optically active. So one optically active compound I am getting and one meso compound I am getting. So option B is the correct answer for this question. Okay. Option B is the correct answer for this question. Clear? Any doubt from this question for anyone in the reaction or in the concept that I have discussed? I hope you all get to know what is meant by meso product from this question, right? Yes? Yes or no? Shall we go for the next question? All right. Question number 4. Assertion. A solution of the product obtained by heating a mole of glycine with a mole of chlorine in presence of red phosphorus generates a chiral carbon atom. Is it true? A solution of a product obtained by heating a mole of glycine. So what is meant by glycine? Carbon, which is attached with two hydrogen, CH2, COOH, and NH2. This compound is called as glycine, right? I also told that glycine is the only optically inactive amino acid. Okay, both of them are hydrogen. When 1 mole of glycine is treated with 1 mole of chlorine, 1 mole of chlorine in presence of red phosphorus creates or generates a chiral carbon atom. Let's see. The name of this reaction is HVZ reaction. If you remember the aldehydes, ketones and carboxylic acid lesson, at the end of carboxylic acid chapter, I have discussed HVZ reaction. Okay. So in HVZ reaction, what will happen means the alpha hydrogen, one of the alpha hydrogen will be replaced by the halogen. So we have two alpha hydrogen, right? What is meant by alpha hydrogen? The hydrogens which are attached to alpha carbon are called as alpha hydrogen. So what are alpha carbon? The carbon which is adjacent to COOH is called as alpha carbon. Okay. The carbon which is attached next to COOH is called as alpha carbon. So these two are alpha hydrogen. So one of the alpha hydrogen will be replaced by the halogen which we are using. So the halogen is chlorine. So replace one of the hydrogen by chlorine. So you will get CH, Cl. I am replacing the above hydrogen, okay? And COOH and NH2, that remains same. Now you see here, we have 4 different groups attached to it. Hydrogen, NH2, COOH and Cl. So since 4 different groups are attached to this carbon, it is a chiral carbon. So on doing this reaction, we are generating a chiral carbon atom. Okay. So assertion is true. Assertion is true. Let's come to the reason. A molecule with 2 chiral carbons is always optically active. Is it so? No. A molecule with 2 chiral carbon is always optically active. No. So in this molecule, we are having only 1 chiral carbon, right? We have only 1 chiral carbon. So the reason is false. Assertion is true, but the reason is false. Clear? Clear for all of you? A molecule which has 2 chiral carbon is not always optically active. In the previous case also we have discussed, right? We had two chiral carbons only, but it was a meso product. It is not optically active. It was inactive. So every time 2 chiral carbon containing compounds are not optically active. Okay? Not always optically active. Clear to all of you? Shall we go for the next question? Shall we go for question number 5? Shall we solve question number 5? Yeah. The incorrect statement regarding enzymes is, so this was the question I told you when I was discussing the enzymes. Okay. So the incorrect statement we have to find out. So we have studied that enzymes are biocatalyst. That is correct. And like chemical catalyst, enzyme reduces the activation energy of bioprocess. That is also correct. Enzymes are polysaccharides. Is it so? No, they are not carbohydrates. Only under carbohydrates we will study polysaccharides and all. The enzymes are not at all a carbohydrate. It is a protein, right? It is a globular protein. So it is incorrect. And enzymes are very specific. That is also correct. So these are the points we have discussed in the class itself. So they are protein molecules which are made up of very high molecular mass. They are not polysaccharides. So option C is the correct answer for this question. Okay. Option C is the correct answer for this question, which is the incorrect statement about enzymes. Is it clear? Is it clear? So all the remaining points are already given in the book and also we have discussed in the class. The only incorrect answer is option C. Okay. Now coming to question number 6. Which one of the following is a water-soluble vitamin that is not excreted easily? So one thing I would like to add to this vitamin topics from this question. Okay. So I will give the answer for this question. I did not mention this in the class. Okay. So the answer is vitamin B12. So it is a water soluble vitamin, but it is not excreted easily. Okay. Means it is an exceptional kind of thing. Water soluble vitamins means it should be excreted through urine easily, right? But the only water soluble vitamin which is not excreted easily is called as vitamin B12. Okay. Just have a note of it. Just have a note of it. In that water soluble vitamin, you just write exception and write this vitamin B12 under it. Okay. So just add this to your notes. Vitamin B12 is the only water soluble vitamin which is not excreted easily. All right. Finish writing. Shall we go ahead with question number 7? Question number 7. Yes or no? Okay. Question number 7 is, which of the following is not an example of fibrous protein? Keratin, albumin, collagen and myosin. We study two different types of protein, fibrous and globular. If you remember very carefully and if you remember properly, albumin will come under which protein? Globular protein, right? So it is not an example for fibrous protein. Keratin, collagen and myosin, they are all the examples for fibrous protein. Okay, so albumin is an example for globular protein and not fibrous protein. Very easy question. Okay, so now let's go for question number 8. The correct representation in six-membered pyranose form for the following sugar is. So which is correct for the following sugar? So this is the sugar and we need to find out which is correct for the following sugar. I told you how to draw the pyran ring, right? The elements which are coming at the right side, they has to come to the bottom. So this is carbon number 1, carbon number 2, 3, 4, 5 and 6. So the hydrogens or the OH which are attached to the right side, they have to come to the bottom part in the pyran ring. Okay. So this is carbon number 1 and this is 2 and this is 3. And if you see for carbon number 3, OH is at below. But for carbon number 3, hydrogen is right side. Hydrogen should come. So it is not the answer. And here also the same thing. To carbon number 3, we have OH. Option B is also incorrect. And if you come to option C, to carbon number 2, we have OH at the bottom. But to carbon number 2, we should have hydrogen at the bottom. Okay, we are supposed to have hydrogen at the bottom. So option C is also incorrect. So the only correct answer is option D. Okay, this is carbon number 1, 2 and 3. So 2 and 3 have hydrogen at the bottom and 4 is having OH at the bottom and this is carbon number 5 and this is carbon number 6. Okay. So the correct representation is option D. Option D. Can you all able to understand? If you look into the fifth carbon, the OH is to the right side. OH is to the right side and H is left. Okay, you should not look this OH. You should only see H. H is left, but it will come down. So it is an exceptional case. It is an exceptional case. The compound or the group which is present at the left will come at the bottom for the fifth carbon. Okay. But for the remaining carbons, carbon number 2, 3, 4 and all, it is same only. So the right side group will come below, left side group will come above. But for fifth carbon, the left side group will come below and the right side will go and form the ring to the carbonyl group. All right. Just keep these things in your mind. I'll go for the next question. Which of the following is a basic amino acid? Which is a basic amino acid? We have studied 3 different types of amino acid. Acidic amino acid, basic amino acid, and neutral amino acid. So which one is a basic? Basic means NH2 group should be greater than COOH group. NH2 group should be greater than COOH group. Okay. So I'll go for the solution. I will give you the list. So see here, this is a list of amino acid. There are only 2 acidic amino acid. One is aspartic acid and the other one is glutamic acid. Okay. So these 2 are the only 2 acidic amino acids. Just keep in mind. Aspartic acid, glutamic acid. And there are only 3 basic amino acids. Arginine, histidine, lysine. Arginine, histidine and lysine. So only these 3 will fall under basic amino acid. Okay, so now you can find out the answer, right? So which is there in the option for basic amino acid among these 3? Arginine is not there. Histidine is also not there, but lysine is there. Option C is the correct answer. Option C is the correct answer. Just remember the acidic and basic and all other 15 will follow under neutral. Okay, there are only 20 amino acids. 2 acidic, 3 basic, remaining 15 are neutral. So just memorize aspartic acid and glutamic acid are acidic. Arginine, histidine and lysine are basic and the remaining 15 are whatever might be the other compound. They will fall under neutral. Okay. Is it clear to all of you? Is it clear to all of you? Shall we go for one more last question for the session? I hope everything is clear so far. Do you have any doubts from question till question number 9? Students? Shall we go for the last question for the session? Okay. Statement type question. Statement 1. Maltose has 2 alpha D glucose unit linked at C1C4 and it is a reducing sugar. So if you remember the informations that I gave for maltose under disaccharides, you can give me the answer by writing. Maltose is a disaccharide. Disaccharide means 2 units will join together. Okay. And 2 units of maltose are alpha D glucose only. Both of them are alpha D glucose. And the linkage, if you see the carbon number 1, the carbon number 1 would have formed that linkage, that glycosidic linkage with carbon number 4. Okay. With carbon number 4. So C1C4 glycosidic linkage is present at maltose and it is a reducing sugar. The only non-reducing sugar is sucrose. All others are reducing in nature only. Okay, statement 1 is correct. Coming to statement 2. Maltose has 2 monosaccharide. One is alpha D glucose and the other one is beta D glucose. That is incorrect. Because in statement 1, I told you both of them are alpha D glucose only. Okay. So the second one is also alpha D glucose. It is not beta D glucose. It is not beta D glucose. Okay. And the linkage is also C1, C6. That is incorrect. C1, C4 is correct. And it is a reducing sugar. It is not a non-reducing sugar. Okay. So if you find out that statement 1 is correct, then obviously you can say that for sure statement 2 has incorrect one. Okay. So everything is the opposite. Statement 2 is just the opposite of statement 1, right? So you should know to find out which one is correct. Then you can eliminate the other. Okay. So statement 1 is true, but statement 2 is false. Statement 2 is false. Okay. So with this, we are completing the biomolecules chapter. And I hope all the concepts, all the topics that we have discussed in this lesson are very useful and it is very clear to all of you. Do you have any doubts from the session? Do any of you have any doubts from the session? Is everything clear? Okay then, thank you so much students. Have a nice day. See you all with the next lesson in the next class. Okay. Thank you so much for attending the class. Take care. Bye-bye.